All right, now that we are recording, remember once again that we were doing factorization, and irrespective of whether you've come to the previous stuff or not, whether you've done factorization or not, any of that, this stuff that I'm presenting in all of these sessions is purely self-contained. So I'm going to give you all the information you will need for the work, because that is the point of a lesson. All right. So here was the homework that I gave you. I quickly tried to do these mentally. So if there's a mistake, it is possible. I doubt it because I was feeling quite strong mentally today, but you never know. I mean, I have been lied to in the past, so my brain may have lied to me. If you have questions on this, feel free to let me know now. So as you're marking, you're going through, I got something different than you. All right, well, let's have a look at what you got different and why you got it different. If you didn't do your homework, shame on you. For shame. Shan, shan, shan. So luckily these ones weren't too bad. You just got to watch out for some of the signs. So here you take out a minus to make an A minus B. Here you take out a minus to make an X minus Y. Here you take out a minus to make a B minus C, etc. And then these ones, you just had to distribute the X in, but then you would still group the first and the second, the third and the fourth, and you came out. Please will explain number 5 and 6 of the last ones. 5 and 6, good. I was waiting for someone to say that. Buddy is hearing an echo. Just make sure it's not personalities chatting to each other. All right. So, annotate. All right, so if we have a look at number 5, we've got a squared minus b squared minus a plus a minus b. So the reason this was told to you to be careful is because this is a difference of 2 squares. So if I decided to group those two and those two, because they got the same thing, I take out an a, I get a minus 1. Take out a b, I get b minus 1. I've got no common brackets. Does not help me. But if I take this dots here, the difference of 2 squares, and I factorize it, no brackets, I see that I've got an a minus b and an a minus b. So I can therefore take out this a minus b. But remember, how am I going to group this? If I keep the plus on the outside, I don't have to worry about my middle signs, and that's how come I can put brackets in there without changing anything. So I'm now going to take out a minus b as my common. And then what am I left with? I'm left with an a plus b over here, plus, but what am I going to put here? I've taken out this whole thing. But remember, when I say take out, I mean I'm dividing by a minus b. And when you divide and they cancel, it leaves you with a 1. And that is where this 1 has arrived from. Why I've got 3 terms here, because it's a plus b, this whole bracket, plus 1. Similarly with this one, it's exactly the same. You just need to group those 2 and those 2. And then again, it's difference of 2 squares, take out the minus bracket, and then it's p plus q plus 1. Okay, cool. We've got a solid 29 people here today. Can you do question 1 of the second set? Sure. So, question 1. So we've got x squared plus x, 3 plus y plus 3y. All right, so distribute the x in. You get x squared plus 3x plus xy plus 3y. So we're going to group these 2 and these 2. Again, after the grouping, we look for a common factor. See, there's a common factor of x. Then we have x plus 3. If we have a look at here, we have a common factor of y, and both of them are plus, so we probably should keep it a plus in the front. taking out a y, we've then got an x plus 3. Bingo! Common brackets, x plus 3. And then we're left with an x there and a plus y here. All right, so that should be all that we need. I will clear this off in 5, 4, 3, 2, 1, 0. Oh, all right. I don't need to annotate anymore. So, as a generalized revision set of questions, you can take these 2 sets of 20 questions. I will send out the answers via intercom so that we don't spend more time on this. And this is a whole range of stuff. Please take note, number 7 is something I haven't 100% done with you. That is when you group 3 by 1 instead of grouping 2 by 2. Remember I said to you, it happens so seldom it's not worth doing. But just to see if you can, you group those 3 into a trinomial, and then you're going to do a difference of 2 squares after that. So it is incredibly seldom you deal with this. That's why there's literally only 1. But yeah. And then after this, that is the end of our factorization lessons, which is great. Yay! Yay! Well done, you made it. All right. So for those of you that joined late, you had a bit of an easier road to try and make it through. Now, the big question is, what do we move on to next? And after the very first session, I asked you guys, what do you want these lessons to be on? And the answers that I got were rational numbers, matrices and trig, similarity and vectors, and graphs. Personally, I believe matrices, trig are very good options because they are quite big sections, especially matrices where it's quite a weird concept, nothing really links to it. Ah, that was good. All right. I feel like today, since we are already into a lesson, I'm going to start matrices, and then we can work from there. So I'm going to end the share. All right. I'm going to whiteboard it. All right. So I'm now going to try another style of lesson to see how this one works, because me being a scientist and all, it's all about experimentation. So I've tried the PowerPoint for factorization. Matrices, I'm going to do a pure handwritten and then see how we go from there. And then you guys can let me know how you're working, which one's better, if you really can't read my handwriting, what's going on. All right. So matrices. Matrices, a lot of the time that you will deal with these is when you come to simultaneous equations. So if you have something like x plus y equals 3, x minus y equals 1. And I say to you, solve for x and y. Ma, ha, ha, ha. Well, in a situation like this, luckily, you could actually have a look at that and do it purely by inspection. You say, well, let's try some numbers. What adds up to 3? 2 and 1. All right. Is the difference between them 1? Yes. Oh, look. Therefore, x is 2 and y is 1. Yay, I survived the question from the maths lord. Yay. Well, sometimes, and when I say sometimes, I mean the absolute majority of the time, this sort of system of equations is not going to be that simple. And you will also come across a time where you might end up with the following situation. And now I say to you, feeble-minded people, you think you can defeat me when I give you a 2x2 and only x and y with 2 equations? I will show you. Here you have 3 equations and 3 unknowns. All right. Then what do? Well, you have a couple options. You can just roll into fetal position, rocking forwards and backwards, going, I am unworthy. I am unworthy. But that won't solve the problem. You might want to run away, screaming, save me from the math lord. Oh no. It can be like vernacular. Don't bite me. Don't bite me. But that still won't solve the problem. So there is a way of solving this through normal simultaneous equations. It's not very pleasant. Can you hide? Well, good question, Siobhan. Can you hide? Essentially, yes, you could, but I have the all-seeing eyes. I will know where you are. So unfortunately, again, not a good option. So matrices is something that's very interesting because it actually kind of compresses all of the complication and all of the excess fluff that you have. And you literally look at just the coefficients that you're going to be dealing with. So in this, we have the equation side and we have the answer side. Now you may note I'm using square brackets, and I'm purposely using square brackets. You can use round brackets. However, it gets a little hard when the system gets really big to draw round brackets nicely. So square brackets are a good option for this. And with matrices, matrices is essentially an array, and an array is a collection of values or a collection or an arrangement of items. You're going to have some rows, you're going to have some columns, but the important part is that each one of these are going to have things called elements, and each of these elements will correspond to a coefficient in one of these equations. So what I can tell you is that I've set up this so that x is still 2, y is still 1, and z, said my mental maths wasn't very hard, was simply 0. Now you might say, oh, how am I meant to know that? Well, you aren't meant to know it, you're meant to work it out. So I'm going to show you how to solve this over here. So what are the coefficients here? Well, let's have a look. If I want to make a matrix of coefficients from this, the coefficient of x is 1. The coefficient of y is 1. Please note I'm not putting the plus in specifically so it doesn't make you think like this is one whole expression. The coefficient of x over there is 1, and the coefficient of y here is -1. But Ricky, you just said I'm not putting the plus in so it doesn't make it seem like it's an expression. That kind of looks like an expression. Well, you have to put in the minus, else you'll never know that it's a negative number. So just back off. Okay. So this matrix is representing the coefficients of this over here. And it's very important because there are 4 distinct elements in this. One element, one element, one element, one element. So we can see that this matrix or this array has 2 rows, row 1, row 2, and then it also has 2 columns, column 1, column 2. Very nice. Now, there's also, because we have kind of like a row and a column, there should be a way of being able to specify a particular element in this matrix. Well, if we think back to something that we should know very well, like the Cartesian plane, we know that on a Cartesian plane, we have something very similar. What we have is we have an X and a Y, a horizontal and a vertical, a horizontal rows and a vertical columns. And if you want to say this piece over there, you gave the X value that you had and you gave the Y value that you had. Therefore, to specify a value here, we're going to specify the row that it's in and then the column that it's in. So I can call a matrix, let's say A. All right. Generally, matrices are referred to using capital letters. If you want a small letter, that will then refer to the element inside that matrix. So this first one over here, you can use little a to denote that. And then this element is in the first row, so it's 1, and the first column, so it's 1. Some people put a comma between them. You can if you want. You don't have to. Those 2 notations are both perfectly acceptable. Just don't think that this is A11. It is not A11. It is A11. All right. Then if we keep going along here, this is going to be A. I'm still in my first row, but I'm now in my second column. I'm still in my first row. I'm in my third column. But if you go down, I'm now in my second row and my first column. Second row, second column. Second row, third column. If I go again, third row, first column. Third row, second column. Third row, third column. And you can have as many as you need. Once again, I mention, this is not A22, it is A22, row 2, column 2. This is not A32, it is A32, A matrix, 3 row, 2 column. All right. So we will continue matrices next time. Remember that I gave you factorization revision work to do. And after this, introduction, we're going to be going on to how to actually calculate stuff, how you work with matrices, how you do operations like adding, subtracting, timesing, dividing. And then we're actually going to be solving sets of equations to show you how you actually do stuff. I will tell you what is in the curriculum and what is slightly above. Sometimes I will have to go slightly above just so that we can actually get a reason for learning this stuff.